Welcome back to another episode of Dave Does Math from Home. Today we are talking about, oh, I changed the name. I forgot to change the number. Sorry. This is section 2.4. More on slope is what we're talking about. We talked a lot about slope in the last two videos. We were doing slopes and point slope forms and we were creating lines and it was great. There is more that we need to say about slope before we can set that to rest. Mostly we need to talk about what parallel means in terms of slopes, and we need to talk about what perpendicular means in terms of slopes, and then there's a couple loose odds and ends that we need to pick up that I may have forgotten to mention in the last video. So we're going to start with parallel. Parallel, in terms of geometry, parallel means two lines that never cross. So they run side by side indefinitely forever. If one of them is off by a little bit, they will eventually cross and intersect and then spread out. But if they're parallel, they never cross on the plane. Sometimes you get lines that cross on other weird shapes. Like if you put parallel lines on like a donut shape, weird stuff can happen. But on a plane, parallel means that it never crosses. And in terms of slope, this means if two lines are parallel, that means that they have the same slope. So this is going to come up in questions like, I guess in some ways this has sort of already come up a little bit in section 8.1. When we were doing section 8.1, we were looking at things like 2x plus 3y equals 5, and then like 4x plus 6y equals 18, something like this. This is a system of linear equations, and we were looking for the point where these two lines intersect. And one of the possible outcomes of trying to solve these systems of equations is we find that there is no intersection, which means that as functions, these two lines are parallel. So we've touched on this idea before briefly. And we can see what that looks like. If we do elimination here, we can multiply this by -2. And we'll keep this one the same. And that will give us -4x minus 6y equals -10. This is 4x plus 6y equals 18. And if you add these two functions together, you get 0 plus 0 equals 8, which is obviously not true. These lines are parallel. In terms of the actual slope we have here, we can sort of look at what's going on by converting these into slope-intercept form. Here's a quick fact that I probably forgot to mention in the 2.3 videos. This form that things are in right now looks like ax plus by equals c. This is called standard form, which I hate, because this is the least standard of all the forms you can put a line in. This is the least used, it's the least commonly recognized. The form that's actually the most standardized is slope-intercept form, but for some reason it's not called standard form. This one's called, anyway. I hate the names of these things. But if we transform these guys from standard form into slope-intercept form, we can get a look at their slopes very directly, and that might help us. So I'm going to erase this and start transforming functions from one form to another. Transforming this into slope-intercept form basically just means that we want to isolate the y term. So we're going to subtract 2x from both sides, and that will give us 3y equals -2x plus 5. And then we can divide by the 3, and we get y equals negative 2/3 x plus 5/3. So all we need to do is write it like this, and we can see that the slope is negative 2/3, and the y-intercept is positive 5/3. Let's look at this one. I want to subtract the 4x from both sides, so I get 6y equals negative 4x plus 18. And then I'll divide everything by 6, and this will become y equals negative 4 over 6 is also negative 2/3 x. This one will be plus 3. So we can see that they do in fact have the same slope. That's the y-intercept. So this one does a y-intercept at 5/3, so a little less than 2. This one does its y-intercept at 3. But aside from that, they are perfectly parallel. They're both sort of going down at the exact same rate. Negative 2 units on the y for every 3 units over on the x you go. So that's what parallel means. The big questions you're going to encounter in terms of parallelism are, you're going to be given some information about some lines, and that information is going to include what it is parallel or perpendicular to, or something like that. And you'll be asked to create the equation of that line. So let's try one of those so we can see what that looks like. Let's find the equation of the line parallel to, we'll do a standard form thing. Let's do 3x minus 6y equals 15. Sure, that one seems good. I want the equation of the line parallel to 3x minus 6y equals 15 through, let's send it through the point 2, 4. So we remember from the last section that if you want the equation of a line, you need 2 pieces of information. You need to find the slope, and you need to find a point. Those are the 2 pieces you need to use for point-slope form. It's very excellently named. There's lots of things in math that I hate the name of, like the standard form of a line. Point-slope form has a really good name. We like that one. So we need a point, we need a slope. We have a point. That was just given to us. That's excellent. We do not currently have a slope. All we know about the slope right now is that it's parallel to this thing. So what we need to do is we need to find out what the slope of this is. And then if we know what the slope of this thing is, that means that we can use the parallelism to know the slope of this thing, and then we'll be all set. So I'm going to discover the slope of this by transforming it into slope-intercept form. So I'm going to subtract 3x from both sides. That will give me negative 6y equals negative 3x plus 15. And then I'm going to divide everything by negative 6. So I will get y equals negative 3 over negative 6 is 1/2 x. 15 over negative 6 is 5 halves, negative 5 halves. If you take the 3's out, that sounds right. Here's what's cool about this. I don't actually care what this is. This is meaningless. It's perfectly irrelevant to the problem. Doesn't matter. The only thing I care about is the slope of this line, so that I can use this slope and this point to create my new line. So We're going to do slope-intercept form. Looks like y minus y1 equals m times x minus x1. I still write the whole thing out every time. Been doing it for 20 years. When was I in algebra? 25 years? It's been a long time. Write the whole thing out every time. Y stays a variable. Y1 is 4. M is 1/2. I know that from the parallel thing. X stays a variable. X1 is 2. That's it. This is your line and point slope form. I do usually want these to be converted into slope-intercept form, so we'll distribute this 2 in there to get 1/2 x minus 1, and then we'll add 4 to both sides. So we have y equals 1/2 x plus 3. This is the equation of the line in slope-intercept form. That's all we needed. So this is how we're going to use parallelism in problems. We're going to create the equations of lines that go through a point that's given and that are parallel to a line that's given. And all we need to do is find the slope of that line and use it with this point in point slope form. It's relatively straightforward stuff. We also need to talk today about perpendicularity. So let me do that as well. Okay. Perpendicular is a really fun concept to think about in terms of slope, especially if you go back to a couple videos ago. I think in the video for 2.3 part 1, I think it was part 1. I hope it was part 1. I think it was 2.3 part 1. I was talking about what various different slopes meant. How fractions meant that it was a very shallow gradient, pretty flat. And numbers bigger than 1 meant that it was pretty steep. So you have that sort of distinction to make between fractions as shallow numbers and whole numbers as steepness. And we also talked about how negative means that you're going down and positive means that you're going, I need to face the whiteboard for this. Positive means you're going up, negative means you're going down. So that's another point that we need to consider for doing things that are perpendicular. So let's imagine for a moment that we have something that has a slope of 2. Let's say we start at, this is what's y equals 2x plus 1. We're going to start at that for our intercept, and we're going to go to 1, 3, and then 2, 5. This thing has a slope of 2. I would like us to imagine for a moment what a perpendicular slope would look like. This thing is positive. That means it's going up. If we want something perpendicular, that means our thing has to be going down. So it has to be negative. This thing has a slope of 2, which means it's pretty steep. If we want something perpendicular, it has to be as shallow as this thing is steep. So since this is a whole number, I need to use a fraction for this thing. That's not exactly, that's a good vague sort of description of this, but like sometimes you'll get really steep numbers like 17 halves. 17 halves is a fraction, but since it's more than 1, it's really steep. Whatever its perpendicularity thing is will also be a flat fraction. But I'm using the word whole number here very loosely to mean something that's bigger than 1, and fraction to mean something that's less than 1. So forgive me for my imprecise language on this one. This is a whole number that's steep. We need, for perpendicularity, we need a fraction that's not steep, is what I mean there. So it turns out, with this in mind, that the perpendicular slope to 2 is negative 1/2. And in general, sorry, I should say perpendicular means right angles. And in general, M1 and M2 are perpendicular. I'm going to just write perp for perpendicular. If M1 is the negative reciprocal of M2. Which is what I was getting at with this sort of demonstration. If you have one number that's like a really big number, however big this is, that means it's the bigness of this number represents steepness, and however steep that is, the perpendicular needs to be that shallow proportionately. So that's why we're using reciprocals. And whichever direction this goes, if this one goes up, the perpendicular has to go down. If this one goes down, the perpendicular has to go up. So we have to use negative and reciprocal to get a perpendicular slope. This is what perpendicularity looks like in terms of slope. We got to make it negative, or I should say, I'm using imprecise language again. I shouldn't say make it negative. I should say use the opposite. Because if it's already negative, then you have to make it positive. So use the opposite sign and take the reciprocal. That'll get you your perpendicular slope. So let me do one quick example of this, and then I'll end this video, and we'll only have one part. So let's find the equation, not the slope, the equation of the line perpendicular to, let's say, 4x minus, we'll do plus, 4x plus 10y equals 17. Through 6, negative 1. So, just like in the other problems, we want the equation of a line. That means we need two pieces of information. We need a point and a slope. We are given the point. Let me write this down. We need a point and a slope. We have the point. Check. The point is 6, negative 1. That's given. We're all set. We need the slope. And all we know about the slope is that it needs to be perpendicular to this. So, much like the last problem we did, I'm going to transform this into slope-intercept form so that I can read the slope off of it very easily. Once I have the slope, I'm going to find whatever slope is perpendicular to that, and that's the slope I'll use to create my new line. So let's start by subtracting 4x from each side. That will give us 10y equals negative 4x plus 17. And now I need to divide everything by 10. And that'll give me y equals negative 2/5 x plus, again, I don't care. This number doesn't matter to me. It's completely irrelevant. The only information I need from this is the slope. So I'm not even going to worry about what that is. I just need this. So this is the slope of the line I'm given. The perpendicular slope needs to be the reciprocal of this with the opposite sign. So this is negative 2/5. That means the perpendicular slope is positive 5/2. If this had been negative 17/4, that means that the perpendicular thing is positive 4/17. You're just flipping it upside down and changing the sign. And that'll get you a perpendicular slope every time. So now I have a slope. It's 5/2. I have a slope, I have my point. Let's put them together. Y minus y1 equals m times x minus x1. Y stays a variable. Y1 is -1. M is 5/2. X stays a variable. X1 is 6. So this looks like y plus 2 equals 5/2 x minus 5/2 times 6 is 15, should be. Because this is, the 2's cancel, yeah, 5 times 3, yeah. And then this is y equals, you have to subtract 2 from each side, so y equals 5/2 x minus 17, and you are done. We are at 20 minutes, which means I am also done.